All right, yeah, so my name is Dan Simon. I am a staff engineer at Tumblr, and today I'm going to be talking to you a bit about building high-performance microservices with Colossus, which is a framework that we've developed and use at Tumblr. So just a little bit about me before we get started. So like I said, I'm a staff engineer. I've been at Tumblr since about 2012, so I've kind of been with the company as we've really grown significantly. When I started, we were maybe about 30, 35 engineers. Now we're close to like 160, maybe more than that. And in general, I've been working with Scala since about 2010. And before that, I was doing PHP. So that was a little bit of a change there. But I think overall it's for the better. So anyway, in this talk, I'm going to be focusing on Colossus, what it is, how we use it at Tumblr, how it works, and also with some code examples of what it looks like when you're using it, and how we made it fast. Because one of the big things about Colossus is that it's really designed to be a high-performance framework. So just an overview about what Colossus is. It's an I/O and service framework written in Scala. It's a fully generalized framework at the core, but the focus that we've had the whole time basically is geared on building microservices. And it's built directly on top of Java NIO, but we also use Akka for most of our thread management and concurrency and things like that. And I'll go into a lot more detail about how that works. And of course, it's open source, and here's the URL. And just as a brief history of where we've been with it, I started working on Colossus towards the end of 2013. And it really started as just a hackathon side project. So the first version I built in 24 hours. And it kind of just sat around for a while. And then a few months later, we decided to try using it in a project, and it worked out really well. So we started to build it out more, productionize it. And then finally, towards the end of 2014, about a year later, we open sourced it. And then since that time, it's grown significantly. And it's come to a point now where it pretty much powers our entire service architecture and a pretty large portion of Tumblr overall. And as I said, the two big focuses of Colossus have been performance and simplicity. So what we're really trying to get is have a framework that makes it easy to write services and to really encourage a reactive and fault-tolerant and scalable design, all the kinds of things that we're really looking for out of microservices. But at the same time, we want to make sure that we introduce as little overhead as possible when doing that. So I don't want to necessarily say that we're trying to make Colossus as fast as possible, but we want to try to make it as efficient as possible. And making it fast is just kind of a corollary of that. And then lastly, we wanted to make sure that the framework itself was very small, focused, and easy to iterate on. And I think that has been a pretty big factor in being able to make Colossus as fast and efficient as it is. Because as we've learned about building services and as we've learned what works and what doesn't, we're able to kind of iterate pretty quickly and change the design and make it better. So just kind of to rehash some definitions just so we're all on the same page, I just kind of want to talk a little bit about what I'm thinking of when we talk about services and microservices. And I'm going to kind of use those two terms interchangeably. But basically what we're talking about is a stateless application server that is more or less geared towards taking in requests and processing them into responses. And usually that's going to be a RESTful interface over HTTP. But not necessarily that's the only way to do it. All of the state is offloaded to databases and caches. And it's designed to be highly concurrent, fully utilizing our multi-core CPUs. And it's generally considered to be part of a larger system. So we're not building all of Tumblr on one service. We have a whole bunch of services, each one handling one particular responsibility. So in other words, the basic takeaways are service owns its data, it encapsulates state in terms of the fact that nothing is able to touch state that it is sitting in front of, so we're talking about databases and caches and things like that. And we're able to scale it horizontally and independently of the rest of the system. And then basically when we think about what kinds of use cases we're looking at specifically with Colossus, we can kind of take a step back and just kind of observe that most of services have more or less the same workflow. And I'll actually give a few examples of where we don't do this, but in general, the basic process is you're taking in requests, you're decoding them, you're figuring out what these requests are asking for. You're then in turn going to be sending requests to these external databases or caches or other services. You're going to be waiting for responses from them, and then you're going to be building a response and sending back to the client who originally sent the request. So in a nutshell, that's basically the scenario that Colossus is looking at addressing. So now I'm going to spend a little bit of time and focus on how we use it. And also, we'll talk a little bit about what Tumblr looks like in general before I go into how we actually use Colossus in Tumblr. So we're by no means a full microservice architecture. We're very much kind of in this PHP monolith system. But more and more over the years, Scala services have been taking an increasingly large responsibility in terms of both front-end and back-end features. So while we still have most of the core and legacy functionality in PHP, as we're building out new features, or we're slowly taking some features that needed to scale more independently and we're moving those into services. And at this point, I would say we have a few dozen services in production, so we're not at the point where we have hundreds, but we do have a decent number of services that are running in production. For our data, almost all of our primary data is in MySQL and memcached. So we have hundreds and hundreds of MySQL machines. Many of them are running on SSDs. And then at the same time, we have also many, many MySQL memcached machines. I don't know how many terabytes of RAM we're using, but it's quite a few. But we also have a lot of secondary data, both in Redis, HBase, Kafka. We're really ramping up with Kafka more recently, and also just in general, HDFS has a lot of things like logs and things like that. Collins is another open source project by Tumblr, which is what we use to manage all of our server infrastructure and management and getting our servers set up the way we want them and things like that. And then lastly, we use OpenTSDB to track all of our monitoring and metrics. So we literally have, I think, almost 10,000 individual metrics that are being fed into OpenTSDB, looking at all kinds of various performance and user interactions and things like that across the entire site. So kind of in one diagram, this is sort of what a service at Tumblr is going to look like. And you can see that Colossus kind of sits at the center of everything. And the two big things that Colossus gives us in writing a service is going to be, one, an HTTP server, and that's going to give us like the RESTful interface that we need to process requests and generate responses. And it also gives us the ability to open these connections to other systems, particularly the ones that we're really focused on with Colossus are Memcache and Redis, and also as well other services. But then you can see that we have a whole bunch of other things that we have that make up a service in general that interact with Colossus in various ways. Probably the next most important one is how we interact with MySQL. So we have an in-house library that handles all the logic for talking to our MySQL instances. And in some case, we'll have a single service talking to over 100 databases. So we have a pretty sophisticated library that handles all of the sharding and all of the routing that takes place to make that work. Then we also have libraries that deal with lifecycle monitoring, and this includes everything from making sure that a service starts up and shuts down correctly to monitoring it, and also dealing with getting the metrics that our services generate out to OpenTSDB. And lastly, we have another library that handles all of our configuration, and this includes both deploying services, getting them started up, and also live configuration that can cause a service to change its behavior while it's still running. And I guess the one other thing I'll point out is that we do use Akka actors pretty heavily within our services. So even though a lot of like the core logic can sit entirely within Colossus, we do often move functionality out to actors, especially when we have things like shared state or things we want to wrap like a blocking API. For example, when we're talking to something like HBase, we wrap that whole thing inside of an Akka actor so we can use that in a multi-threaded environment. So here's one specific example. This is one of the last big projects that I worked on myself, and this was Tumblr messaging, which is something that we launched towards the end of last year. And this is basically just private blog-to-blog instant messaging. And it was an instant success. We've had billions of messages sent in that time across hundreds of millions of blogs. And but the one nice thing about this is that the whole backend side is written in Colossus, and the whole thing runs on roughly 6 machines. And for the most part, those 6 machines are only needed for redundancy. We could actually run it on far fewer. And we've had no major downtime since launch. The only really downtime issues that we've had are mostly focused on when we have to do like MySQL maintenance or things like that. But even then, it's been very, very little. And our median latency for this service is about 5 milliseconds, and our 99th percentile is about 15 milliseconds. And I think one of the important things to show is that with this service, probably 70 to 80% of requests are only hitting memcache. So this is one of like the real prime examples of the kinds of services that we're building where we're hitting memcache and MySQL, but probably as much as we can, try to stay entirely within memcache. And that's sort of what causes our latency to go up towards the end, is when we're falling back to MySQL. But even with MySQL, in some of these cases where some of the machines are on SSDs, so we're still able to get pretty low latency and decent throughput. So here's a couple other examples that I'll touch on a bit. So the first one is a project that was created by our search team. It's called WebScale AFDB. And it's basically the idea of taking memcache with MySQL on solid state and then sticking Colossus in front of that and treating the whole thing like a very scalable and durable key value store. So a single node is able, a single service machine is able to handle hundreds of thousands of operations per second, even when those operations are going like are write operations to MySQL. And actually, this is a good example where I was saying before that most of our services use HTTP with a REST interface, but this one actually is speaking the Redis protocol. And so when a client is interacting with this service, it's actually using a Redis client, and it sort of treats it like it's a giant Redis store. And obviously, the only commands that we really support out of that are like get and set and like a multi-get. So we're not doing any of the other things that Redis would normally do, like sets or lists. But we are able to use a Redis client and just kind of, it's a much lighter weight protocol than HTTP. So it really helps facilitate those, the low latency interactions that we're trying to get for. And like I said, this was originally built for search, but now we're starting to look at wider integration into the rest of the site. And the last example that I'll touch on is something called activity pages. So this is a user-facing feature. It's a very basic real-time blog analytics that we provide for all users. So if you have a blog on Tumblr, you can see basic things like how many likes you've been getting, how many reblogs, who are your biggest fans, and things like that. And this is one example where we're not following that strict model of processing requests into responses. We actually have sort of a secondary part of the service where in real time we're reading data out of Kafka and we're writing into both Redis and HBase. So we're using Redis kind of like a cache and then also writing to HBase for our long-term storage. But we still provide an HTTP interface to PHP, which is the consumer of this service. So as you hit the site, you're going to be hitting PHP, and then PHP is going to be making a call out to this service to grab data to show in your activity page. And so these are some of the big examples, but like I said, Colossus is now being used kind of all over the place in Tumblr. So like I said, search, so not just for WebScale AFDB, but a huge portion of the search infrastructure in general is built on Colossus, and this includes both like the offline portions that are doing all of like the ML and recommendations generation and things like that, but also the online portion that is doing things like type ahead and stuff like that. And push notifications, email, logging analytics, we have a ton of things where we have Colossus sitting in front of things like HDFS and other systems. Just kind of general event bus and message processing. And also, we're starting to now focus a bit more on stream processing. So we're currently not using anything like Spark. But like I said, we are really heavily ramping up our use of Kafka. And we're starting to have a lot more integrations with Colossus in that regard. So now I'm going to go into a bit about how it works and also what just a basic service looks like in terms of code. So I guess as like a quick show of hands, has anybody ever written anything either directly on Java NIO or writing something on Netty? Yeah, so I figured it's pretty much nobody. So basically, the model that we follow is kind of the same model that most asynchronous frameworks have to follow nowadays if you're writing anything on top of NIO, which is where you have event loops. And event loops are interacting with the underlying network, and they're pulling events. And you have, for each connection that you're maintaining, you have an event handler that is waiting to process those events as they come in. So all of like the major frameworks are kind of working that way, and in that regard, we're sort of following suit. So Colossus follows this reactive event-driven model where we have multiple independently running event loops, generally one per CPU core, but you're able to kind of configure that how you want. And as I said, an incoming or an outgoing connection is bound to a single event loop for its lifetime. And then the user is going to supply a connection handler for each connection that is going to react to events that come in from those connections. So mainly when new data is available to process, or when the connection closes, or when the connection first opens. These are the kind of events that you're going to handle. So this is a very rough overview of what the core architecture looks like. Like I said, Colossus is built on both NIO and Akka. And the way this works is, at the very lowest level, we're letting NIO do all of this event management and event processing, but all of these event loops are wrapped inside of Akka actors. So you can see here that we have two main actors at play. We have a server actor, which is the actor that actually opens your socket and listens for new connections. And as those new connections come in, it's going to forward them to one of n number of worker actors. And these are the actors that maintain the event loops that process these events coming in on these connections. And this is basically where all of the real guts of Colossus live, inside these workers. So you can see that once the connection is opened, it's going to stay bound to a single worker. And we sort of use a router that sits in front of these to evenly distribute connections to each worker. So the way these worker actors work is, like I said, they're maintaining an NIO event loop. But the way this actually works is we use actor messages to do the looping itself. And what ends up happening is a worker is going to alternate between handling messages from NIO, these low-level connection messages, and then handling actor messages coming in from other parts of the system. And what this gives us is a very flexible system where we're able to very efficiently handle the NIO events, but then we're also able to handle events coming in from other places, and that kind of allows us to integrate the event loops with things like Akka actors and futures and things that kind of sit outside the workers. And this is just kind of, that I included here, just kind of in a pseudocode of what this looks like actually inside the actor itself. So you can see, for example, that we receive a new connection event, and so then the worker is going to take that new connection from that server actor and bind it to its event loop so it can start processing messages. But then it also has a select event, and that's when it actually asks NIO, what are the connections that have events right now that are ready to process? It will go through those and handle all the events, forward each of those events to those connection handlers attached to the connections, and then it will send itself a select message to do that again. So the result of all of this is that most user code is going to be single-threaded. And in particular, when we're thinking about the context of a single connection, everything is going to be single-threaded. And what this gives us is it allows us to do very, very low latency on the kinds of small requests that are very typical of services. So we're not doing any heavy processing in the thread. We're just kind of parsing HTTP requests. We're creating requests for Memcache or creating requests for other services and waiting for those responses. So all of this happens entirely in thread. And then Akka is what's going to be handling all of the thread management and all the thread crosstalk. So we're sending actor messages from workers to the server and from servers to workers, and then also from workers to your own actors that you can spin up and vice versa. And what this ends up giving us is very minimal overhead for concurrent operations, and especially for concurrent operations when you're talking to a cache like Memcached or to another service that's speaking HTTP. And from what I've said here, this might remind you of a framework that is also takes this approach, which would be something like Node.js, where everything is single-threaded. And Node.js gives you sort of that promise where you can get very low latency and it's all asynchronous and reactive. But also one of the biggest criticisms about something like that is you're really stuck in that single thread inside the event loop. And if you want to do something that blocks, or you have something that's CPU intensive, you're kind of stuck, or you have to kind of hack around it. And Colossus's integration with actors and futures really gets us out of that walled garden, where when you have things that really need to be multi-threaded, or things that need to block, or things that are very CPU intensive, where you don't want to block these event loops, then you can just use actors and futures like you normally would. So when it comes to actually building a service, there's two components that you have to provide. The first is the request handler, and this is what I've been saying, where a request handler is attached to each connection, and as events come in on those connections, Colossus is going to take care of all of the decoding and giving you an HTTP request, but then it's up to you to actually tell it what to do with this request. And then the second component is what we call an initializer. And this is something that is created once per worker. And this is sort of where your setup logic, your initialization goes. And this is also where you're going to be able to open those connections to external systems. So real quick, here's a very simple request handler. And as you can see, it's really not much more than just having a partial function that maps HTTP requests to HTTP responses. Now, request handlers can actually do quite a bit more, but I have to kind of just keep it simple for now. And as you can see, the one thing I'll point out here, which I'll get into shortly, is you can see that the return type of this partial function is what we call a callback of HTTP response. And just kind of in one sentence, a callback is sort of like Colossus's version of a future. But we'll get more into that shortly. And then here's an example of an initializer. So you can see this is really not much more than you could call it a request handler factory. But initializers actually do quite a bit more than that as well. But this, again, this is sort of like the bare minimum you need to start a service. And here's basically all you need when it comes to the actual Bootstrap code. So you can see the first thing we do is we start an actor system. And then what we do is we create something called an I/O system. And this is basically the wrapper around those event loops and everything like that. Whoops. That's funny. There we go. Thanks, Chrome. And then the last thing that we end up doing is actually starting the server, where we give it a name, we give it the port to listen on. Obviously, there's a lot more configuration you can supply if you want to. But then the last thing we give it is just a function for creating those initializers. And what's going to happen is it's going to send this function to each of those worker actors that are running, and the worker is going to create an initializer. And then as new connections start to come in, it'll use that initializer to create connection handlers. So everything I've talked about up until now has sort of been like the bare minimum just to create sort of like a hello world service. But like I've been saying, one of the biggest features that we need in Colossus is to be able to talk to external systems, and in particular the low latency systems that we need to use like Memcache and Redis and other services. So in Colossus, you do that by creating clients. And clients are what give you these persistent connections to these external systems. And clients support a codec-based design. I should have mentioned that servers do as well, but right now we're just mostly focused on HTTP. But with clients, we want to be able to support things like the Memcache and Redis protocols, as well as HTTP and other protocols that you might have. So if you've worked with something like Finagle, you'll know that Finagle is built around the idea of codecs, and this is one of the ideas that we borrowed and used in Colossus. So here's kind of what this looks like when you're actually creating a client. So as I said, clients are created in the initializer of a service. And what that means is because every worker has its own initializer, when you open a client, you're going to be actually opening one client connection per worker, which more or less corresponds to one client connection per CPU core that you're running. And then the request handlers that are being maintained by that worker are going to be using that client. And that means that everything is still staying within the worker. And as requests come in and you want to send requests out to Memcache and Redis, everything stays inside the worker and everything is in thread, and all of the asynchronous communication is maintained by the worker itself. So then what this really ends up giving us is what I call concurrency without parallelism, where we get all of the nice asynchronous non-blocking I/O that we want, but everything is done in thread, and this really cuts down on the overhead. So now I'll focus just a little bit briefly on how that actually works. And as I said before, when you are writing your request handler, I point out that the return type is what we call a callback. And a callback is the way that we do all of this in-thread asynchronous operations. And it's sort of a way of doing continuation passing. And this is sort of another idea that I'll touch on with something like Node.js, where when you want to do async I/O in Node.js, you usually do it through continuation passing, where you call a function with some parameters, but then you give it a callback function that will be executed once that asynchronous I/O operation is complete. And the pros about that is it's very efficient. It's a nice, very efficient way to do this asynchronous operations, and it's good for low latency. But then the cons is that you usually end up with code that looks like what I've shown here, where as you do more and more operations, it just starts getting more and more nested, and you end up with what we call callback hell. So the callback type in Colossus basically takes the mechanics of continuation passing and presents it as a monad. And what we end up with is basically something that has almost the exact same API as a Scala feature. So we have map, flat map, recover. We also have things like sequence and traverse and all those things. And it gives us this nice, very efficient, single-threaded asynchronous operations. But now we can do all the things that we like to do in Scala, where as I shown here, we put basically the same code and now is in a regular for comprehension, which is the kind of things that we like to write. And then lastly, this is kind of just a quick example of what code actually looks like a bit. So here's just a simple HTTP interface for Redis gets and sets. And you can see here that we're sort of doing some very basic pattern matching on the HTTP request. We're sending a request to Redis, and then we're mapping on that to produce our HTTP response. So you can see that if you worked with any other Scala framework, like anything from like Play to Finagle to any of these others, it looks very similar, where we're just kind of doing these operations and mapping and flat mapping on them and things like that. And the last thing I'll point out is that clients actually do work with futures. And this is very useful when you want to use like a Redis or a Memcache connection from outside of a worker. For example, if you have an actor that you want to have a connection directly, you can do that. And I guess what this would also say, like if you're looking at this and you're thinking, you know, I don't really want to deal with callbacks, I just want to work with futures like I'm used to, then we do support this where you can just do futures for everything. It's still using callbacks under the hood, but then this gives you the ability to just kind of stick with futures and not worry about that. There is a performance hit when you do that, but it's, in most cases, it probably is not going to matter that much. So that was kind of the basics. And OK, I have a few minutes still. So but that's kind of like most of the use cases that we go for with Colossus, where we're reading an HTTP request, making requests to Redis or Memcache or other services and things like that, and then producing responses. And then when we have to use things like MySQL or HBase or any of these other data stores that we don't have a native Colossus client for, then we can just use futures and just use like things like Slick or other thing or whatever API that they provide. And there's a few other things I'll touch on real quick that Colossus has. Probably the biggest one is our built-in support for metrics. So as I said, we have thousands of metrics going to TSDB, and many of those are given to you out of the box in Colossus. So things like latency, throughput, things like that are automatically generated for you. You can obviously create your own. So we have support for counters, for rates, and for histograms. One other thing that I guess I can't really go into too much detail about, but the connection handlers and the request handlers that I showed you before, they can actually behave a lot like actors. And this is actually important for when we do things that are not quite in, like, things that are not HTTP, like, for example, for WebSocket, which we're adding support for now. You can actually treat your WebSocket connections kind of like actors, and you get a proxy actor, just a regular Akka actor. You can just pass that around, send messages to it, and it automatically gets routed into your low-level Colossus connection handler. And then, like I said, we are adding more support for things that are not typically like the straight request-response semantics of a service. So like I said, WebSocket is one of the big ones we're looking at. We do have support for it now, but it's a bit experimental. And also things like streaming, and also the ability to sort of add arbitrary code into workers that can use things like clients and stuff like that, but aren't particularly actually spinning up a server. So lastly, I'm going to talk about a bit about how we made it fast. And like I said, one of the big focuses of Colossus has been towards performance. And I think in that regard, we've actually really excelled at that. And it's been sort of an ongoing effort to constantly improve performance without sacrificing design. And this graph that I'm showing you here is a kind of a rough gauge of how Colossus has performed in terms of benchmarks since we've open sourced it. So when we open sourced it, we were already kind of going under this pretense that it was a fairly high-performance framework for low-latency things. But over time, we've actually significantly improved that since then. And I guess before I go into the actual looking at a few numbers, I'll just kind of give a quick disclaimer that benchmarks aren't everything. And so obviously, when it comes to benchmarking, usually we're looking at something just like a hello world service that isn't doing anything significant. It's sort of just taking requests and turning them into responses. And that does capture a lot of what a framework has to do, but it's not everything. And it's also very easy to fall into this trap of just optimizing something just for a benchmark and not for the real world. And I think looking at benchmarks and doing these kinds of optimizations actually, though, has really helped us a lot in improving our performance in the real world. So now we'll look at actually some numbers. And so this is, these are some benchmarks provided by a company, Tech Empower. And this is actually a preview run. These aren't actually the final results, but I think the final results, which should be published pretty soon. This preview was run just a week ago. But I think the final results will pretty much be the same. So this is basically showing for a Hello World service. You can kind of get a good idea of where Colossus sits in terms of performance. And we're really kind of taking things to the next level in terms of doing these low latency operations. And then even when we factor in all frameworks on the JVM, we're still pretty much up there. I don't know if this will stay, we might get bumped down or something like that. I'm not too concerned about trying to say that we're the fastest framework on the JVM, but just the fact that we're up there is sort of like showing that we're kind of meeting this goal in terms of writing high performance code. So I'm not going to focus too much on the numbers, but I think it's safe to say that we're doing pretty well in terms of performance. So I want to just talk a bit about what goes into making code like this, because it's been a lot of work to get Colossus to where it is. And what I have here is sort of just a rough breakdown of what I feel has contributed to making Colossus as fast as it is. So by and large, the largest factor of this is going to be just the concurrency model that we've chosen. The fact that keeping as much as we can single-threaded really cuts down on the overhead needed for doing asynchronous operations. So if we think about using things like actors and futures, the overhead is pretty small, but when you start to try doing millions of operations per second, it does add up quite a bit. And the model that we've chosen where we use callbacks, and especially when we're talking to these low latency systems like Redis and Memcache, it really helps us keep latency down and drive throughput up. And then again, keeping things single-threaded makes it a lot easier when we actually do decide to go in and really optimize something. It makes it a lot easier to optimize these performance critical paths. And there's a bunch of other things that gives us, like for example, we really don't have a concept of buffer pools, and this is getting a bit more lower level. But when it comes to just kind of like the really low level mechanics of how we decode requests and encode messages and things like that, we're able to keep things pretty simple. And I guess the last thing is we have a very, one thing I didn't mention was that back pressure is a feature that's built into Colossus across the board. So as I've been talking about doing all these like high performance interactions, back pressure is a very important part of all that to make sure that we're not knocking over systems and we're gracefully handling situations, for example, when we overload Memcache or if we overload another service, making sure that we handle the back pressure correctly. But in many cases, when it comes to the actual internal back pressure itself, we do have situations where we allow things to sort of temporarily exceed their limit to sort of keep things running smoothly, but still have like actual back pressure when things go a little too overboard. And so the next big thing that I feel like factors a lot into our performance gains is basically the idea of optimizing for pipelining. And this is sort of like the one major feature that we actually kind of looked at specifically to optimize for. And this is the idea where if you have a client or if you have a server, you can send multiple requests at the same time before you wait for the first response. And this is something that HTTP, that the Memcache protocol, and the Redis protocol all support. And it's something that we utilize very, very heavily in our system. So for example, when we have like our Tumblr messaging system, when we're sending all these requests to Memcache, we're pipelining them at a very high rate. Sometimes we're sending hundreds of requests all at the same time before we wait for a response. So by not just allowing Colossus to do those kinds of things, but optimizing for those situations gave us a very large performance improvement. And actually, if I just go back real quick when I showed this graph, when we sort of had this big upswing in performance, that was when we were kind of doing that kind of stuff, optimizing for pipelining and things like that. And then I guess the last thing I'll touch on real quick is just sort of like the last bit of like micro optimizations. This is when we really kind of go all out. We kind of take a lot of the nice things that you can get in Scala and we throw all that out. We kind of just basically write Java in Scala. And this is something that we've done very, very selectively, only in like the hottest code paths. But I feel like it actually has given us a nice improvement. And the one thing I'll say is that whenever we do this, we're always optimizing with metrics. So we're never just looking at something and thinking, oh, this might be faster if we did it this way. We're always benchmarking and sampling and things like that to make sure that we actually have a really noticeable gain. And whenever we do these kinds of things, we're always also making sure that we hide these optimizations from the end user, so we're not actually decreasing the usability of the framework just for performance. One of the big areas is just parsing HTTP requests. HTTP is not the most efficient protocol when it comes to parsing, so making sure that you're doing it as fast as possible is actually a larger part of our performance gain than I initially thought it would be. And then a lot of the other things, using just regular old arrays and using Java linked lists in place of Scala collections. You always hear about Scala collections are not that fast, and I would say most of the time we don't really worry about that. But especially like for example, in our HTTP request parser, we had to make sure to use just like plain old arrays, plain old linked lists, because it actually gave us a very noticeable improvement in performance. And then I guess another thing to point out is there are actually a lot of really small little things that you wouldn't necessarily think would lead to a performance improvement, and I guess in most cases they wouldn't. But again, when you're in these really hot code paths, it actually makes a significant difference. So the one that I always think about is just the idea of calling dot size versus dot length on an array. And if you think about that, dot length is built into the array itself, but when you do a call to dot size, you're going to trigger that implicit conversion into like a wrapped array. And just that one little bit of overhead, if you're doing that millions of times per second, it really adds up. And then a few other things I pointed out here, just like composing partial functions and just using plain while loops versus doing higher order functions like map and for each. So again, these are things that I would never recommend anyone do at first. And I would never recommend you do these things in like user-facing code. But when it comes to like the very low-level stuff that we've done, it does help quite a bit. And I'm just about out of time, which is good because I'm basically finished. So as I said, Colossus is actually still under very heavy development. We're not at a 1.0 release yet, I would say. We're still kind of iterating and going forth from there. But as I've shown, even at the state we're in, we're using it for very large features at Tumblr, and it's working out for us very well. So the next big release is going to be 0.9, which is currently like in the release candidate phase. And it has a bunch of big improvements. Probably the one I'd like to talk about just a little bit is the fact that internally, we're now sort of changing everything to look like a stream. So the way things have worked internally now is it's sort of just kind of building things up as we have worked on them. But now we've kind of taken all these ideas that we've had about doing things efficiently with asynchronous operations. Now we're turning everything internally into streams. And I guess that's about it. We're always looking for feedback. I think everything that we've built into Colossus at this point has really been to solve our own problems. But now I'm very interested in hearing about other people trying to use it and seeing, what are some things that other people are running into that we don't handle yet, or maybe things that we could handle better, and things like that. So that's about it. So I guess we have a couple minutes for questions if anyone has anything.
Anyone have questions?
Yeah, we're here.
How big of a performance improvement did you see when you took care of the small gotchas that you had in the last slide?
Sorry?
How much of a performance improvement did you notice when you handled the small, the use while loop versus map flag kind of things?
Oh, OK. So you're asking the performance improvement we got from using just a plain while loop versus map and for each?
Just the small things that you mentioned.
Oh, I mean, I think I put what I put. I said 20%. I think that's a rough estimate of how much of improvement we got from doing some of this stuff. But it matters more in some situations versus others. But yeah, I wouldn't say it was like the thing that made us fast, but it certainly helped. Yeah.
On that use case that you combined Redis with HBase, and you said Redis was like a temporary, what is your procedure when Redis fails, or do you load data from HBase back?
Right, so the question was, let me go back to that slide. The question was, in the example where we are writing data to both Redis and HBase, how do we handle the situations where data is not in Redis? Yeah, pretty much what we do is we'll fall back to HBase, and then we'll do write-through caching, where as we're sending back the response, we'll write data to Redis. I should have mentioned that's sort of the plan that we do for most of our stuff. We do like look aside and write-through caching, where if something is not in cache, we'll pull it from the database, write it back to the cache as we're sending back the response.
Okay. Well, thanks a lot, Dan.
Yep.
Good job.